Electronegativity is a fundamental concept in chemistry, referring to the ability of an atom to attract electrons in a chemical bond. The order of electronegativity from highest to lowest is as you can see in the table. The highest is the fluorine. Then comes oxygen, chlorine, nitrogen. After that, bromine, iodine, sulfur, and carbon. And finally, the hydrogen. So, this order is very helpful for explaining the effects of electronegativity in covalent bonds. Now, to make this order a bit easier to remember, let's use a fun mnemonic. Imagine this. A fox opened a cylinder of nitrogen, broke into a sulfur cave to hydrate himself. As you can see in the image, a fox, representing fluorine, is opening a cylinder of nitrogen. Here, the word opening represents the oxygen and cylinder, representing Cl for chlorine, and the nitrogen representing itself. Next, the fox breaks into a sulfur cave, representing sulfur. Here, breaking is for Br, which is bromine. Into is actually iodine, and the sulfur cave is sulfur and carbon. Finally, the fox is hydrating himself inside the cave. The word hydrating is for hydrogen, and that's the story ends with the order of electronegativity. Why electronegativity is important. Electronegativity is a key factor in determining Number 1. Bond polarity. It influences whether bonds between atoms will be polar or nonpolar, affecting the physical and chemical properties of substances. And the bond polarity is important to explain the inductive effect. It plays a critical role in explaining the inductive effect, especially in organic compounds where electron withdrawal or donation impacts molecular reactivity. And the ionic properties in covalent compounds. The difference in electronegativity between atoms in covalent bonds can lead to ionic character, which is essential in understanding compound behavior. And the chemical reactivity, electronegativity, helps predict how atoms will interact, influencing reaction mechanisms. Additionally, we can see that high electronegative elements make great oxidizing agents. For example, fluorine, F2, is the strongest oxidizing agent. And the low electronegative elements make good reducing agents. For instance, sodium is a strong reducing agent. Besides, hydrogen bond, which is very crucial in various biological processes, is also influenced by the electronegativity of atoms. By understanding electronegativity, you unlock a deeper understanding of chemical reactions, bond formation, and molecular interactions. It's a concept that's essential for grasping the intricacies of chemistry.